We have, it says that the prep course was offered to them with the expectation to improve their scores. That means this population mean mu, which is 25, that is supposed to go up. So based on that information, our alternate hypothesis will be mu greater than 25, and then on top of that, the question is also telling you to use a one-tail test. Remember the directions? We can have three types of things. We can have a greater than sign, that's one tail. We can have a less than sign, that's one tail. Or we can have not equal to sign, that is two tail. So it's one tail test, and the information we are given, that tells us the alternate hypothesis will be mu greater than 25. So, and what else is there? Our alpha is given. Alpha equal 0.05. Degrees of freedom is 9. So we need to find out the T critical. This table. So we look at this table and look for the information. One tail test, alpha 0.05. So one tail test here, alpha is 1.05, degrees of freedom 9. So the T critical is 1.833. Did you see it? T critical. That's the T critical value. And we learned on Thursday that if your T of 10, meaning the calculated T value exceeds T critical, then you reject that null hypothesis. That's what we learned last time. That's what we had in this thing here. So let's see, look at this calculation here. So we are given this sum of square, which is 46. We need to find out the standard deviation. Why? Because we need to calculate the standard error. The T of 10 n or x bar, either one of these, minus mu divided by standard error of the mean. To calculate the standard error of the mean, to calculate that one, we need to find out the value of S, or what is S stand for? What is this S we are talking about? Yeah, I have given you the formula right there. This is variance, this is standard deviation. So we need to find out the standard deviation first. So step number 3, this is step number 1, this is step number 2. Step number 3 is we calculate this standard deviation. So we calculate the standard deviation. Next step, we need to calculate this standard error of the mean, SM. So we go back to this one again. standard error of the mean equals S, which is this value here, divided by square root of n. So it's 2.26 divided by square root of 9 equal 2.26 divided by 3, and we get 0.72. So this value is determined. Now we have to calculate that T of 10. This is the next one. So we'll write T of 10 equal, or X bar was 29 minus mu, which is 25, divided by the standard error of the mean, which is 0.72, which is 4 divided by 0.72 equal 5.55. So the T of 10 is definitely higher than this T critical. Since it is higher or larger than T critical, we reject the null hypothesis. So this is how we write. So we will write reject H sub 0. We write it as T, and then right here within parentheses we write down the degrees of freedom. Degrees of freedom here is 9 equal okay. One more thing I have written here, P less than 0.05. If you look at this, my handwritten stuff, you may write it, you may not write it, you don't need to write that. If you just write, reject H sub 0, and then you just write down T within parentheses, degrees of freedom, depending on what your n size is. If your n is 15, then degrees of freedom will be 14. Then you write down the equal sign, and then write down that, and then you